Welcome to the lesson on additional quality philosophy and management strategies. Upon completion of this lesson, learners will be able to compare and contrast the four founders of quality and their philosophies. Compare and contrast the most common quality management strategies and describe how productivity and costs are related to quality. Quality management systems were not created in a vacuum. Various intellectuals envisioned a manufacturing environment in which quality was priority. This created various quality management systems that complement each other. These systems incorporate fundamental quality philosophies, structured management approaches, and careful balancing of quality with productivity and costs. They also must operate within legal frameworks that govern product safety, liability, and consumer protection standards. Many researchers have contributed to the field of quality improvement and management, their philosophies shaping current management strategies. The most notable of these are W. Edwards Deming, Joseph M. Juran, Armand Feigenbaum, and Junichi Taguchi. Edwards Deming made it his mission to create effective organizations through optimal management strategies and practices. He encouraged top management to be involved in creating an environment that promotes continued improvement. A statistician by training, Deming introduced statistics into quality control. Deming defined quality as systems without faults, a goal that an organization needs to strive for. Joseph M. Juran is considered one of the founding fathers of the quality control and quality improvement field. His philosophies focused on three areas: planning, control, and improvement. These are now known as the Juran Trilogy. Juran traveled to Japan in 1954, where his principles were well received and implemented. He met with several companies and lectured at well-known universities. According to Juran, there are three elements to quality management: measuring a parameter, comparing to a standard, and taking action if the standard is not met. Juran is also credited for introducing quality circles to the United States. Quality circles are teams of employees at any and every level that drive the organization's mission of quality. Armand Feigenbaum, born in 1920, introduced the concept of organization-wide quality control in their book Total Quality Control. Published in 1951, it heavily influenced early quality management philosophies in Japan in the 1950s. In the December 1997 issue of Quality Progress, Feigenbaum asserts that quality should be a method of managing, operating, and integrating the marketing, technology, production, information, and finance areas throughout a company's quality value chain, with the subsequent favorable impact on manufacturing and service effectiveness. Junichi Taguchi's contribution to quality management systems was the perception of quality, or the lack of it, as a loss to society, where society is defined as a team within the organization as a whole, or the entire community. He developed methods for ensuring consistency of performance in order to reduce variation in products by identifying key product characteristics. Taguchi explained that any variation from the specification of a product causes loss. To make his case to organizations, he associated this loss with a cost value. He clarified that variations led to defects: poor fit, poor finish, oversizing, undersizing, scrap, reworking, warranty claims, and most importantly, loss of customer goodwill. Let us shift focus to quality management strategies. The integration of systematic processes, clear documentation, continuous monitoring, and comprehensive employee training forms the foundation of several key methodologies that ensure consistent product quality and meet customer requirements. These approaches include total quality management, abbreviated as TQM, just-in-time manufacturing, Six Sigma, and the Tim Woods model of lean manufacturing, which identifies and eliminates 7 types of waste in production processes. Each of these strategies, while distinct in their specific approach, shares the common goal of improving product quality and operational efficiency through systematic improvement methods. We will discuss these strategies in detail in the upcoming slides. Total Quality Management, also called TQM, is a quality management strategy for implementing and managing quality improvement activities on an organization-wide basis. TQM began in the early 1980s and was impacted by the philosophies of W. Edwards Deming and Joseph M. Juran. In TQM, employees at all levels are involved in the establishment of quality teams or circles. Four key aspects of TQM include top management commitment and involvement, use of statistical methods and the recognition of variation as a loss, specific quality and business objectives at all levels of the corporation, and emphasis on technical education that provides means for career development. Initially known as the Toyota Production System, Just-in-Time was developed in Japan and implemented in the Toyota Motor Company in the 1980s by Taiichi Ohno. It is often said that the just-in-time production system was culturally driven because of Japan's history of space and resource limitations. The goal of this strategy is to have each workstation acquire the required materials from the upstream workstations as needed, or just in time. Just in time has set 7 goals: 0 defects, 0 inventory, 0 setups, 0 breakdowns, 0 handling, 0 lead time, or time to provide materials, and 0 surging, or parts produced when needed. Each goal, as explained by Ohno, implies a level of perfection not ever attainable in a production process. However, the concept of a high level of excellence is important because it stimulates a quest for constant improvement through imaginative attention to both the overall task and to the minute details. The Six Sigma methodology was developed in the late 1980s by Motorola due to an increased demand for its products. This methodology focuses on reducing variability in key product characteristics where a failure or defect can result in product deficiencies. Reducing variability impacts quality standards in the product and organization. Sigma is a term and symbol used in statistics to represent standard deviation, an indicator of the degree of variation in a process. The figure you see here shows the distribution of two processes with the same mean but different standard deviations. Process 1 has fewer defects because its variation is smaller, whereas Process 2 will have more defects because of its larger variation. At 6 sigma or 6 standard deviations, there are only 3.4 defects per million opportunities. Used in the manufacturing environments for the past 2 decades, 6 sigma has been adopted by many industries, including banking, healthcare, and service industries. Lean manufacturing principles aim to create a simple and efficient production environment by considering the use of resources with the goal of creating value for the customer and reducing waste. Developed by the lean manufacturing experts at Toyota, TIMWOODS is an acronym for the 8 wastes found in manufacturing: transportation, inventory, motion, waiting, overproduction, overprocessing, defects, and skills. Transportation involves unnecessary material movement, while excess inventory ties up resources and space. Motion waste occurs through non-value-added movement of people or equipment, while waiting creates idle time between processes. Overproduction means making more than needed. Overprocessing adds unnecessary features, and debate effects lead to rework and scrap. The 8th waste, skills, refers to underutilizing employees' capabilities, knowledge, and creativity. By systematically addressing these wastes, organizations can optimize efficiency, engage employee effectively, and reduce operational costs. Quality and productivity of an organization are integral to each other. An effective quality management system impacts both productivity and cost. For example, by increasing quality in the system and reducing variability, products are less likely to be scrapped or to need reworking. This, in turn, increases the demand for the product, increasing the productivity of the manufacturing facility. The increase in production that results from the implementation of a quality management system results without the need to invest in new machinery or workforce. Finances are also part of an effective quality management system. Organizations must understand the cost related to quality throughout the process. Generally, these costs are associated with producing, identifying, avoiding, or repairing products that do not meet specified requirements. Many organizations have established 4 categories for classifying these quality costs: prevention, appraisal, internal failure, and external failure costs. We will explain these in more detail in the upcoming slides. Prevention costs are those associated with the efforts in product and manufacturing design that, in turn, lead to the prevention of defects and deviations in the product. Some prevention costs include quality planning and engineering, new product review, product and process design, process control, training, and quality data acquisition. Appraisal costs are those associated with measuring, evaluating, or auditing products, components, and purchase materials to ensure that they meet the standards imposed during the design phases. Some appraisal costs include raw material inspection, product inspection, the materials and services used during inspection, and the maintenance of inspection equipment. Internal failure costs are those associated with the failure of products, components, materials, and services to meet quality requirements prior to product delivery. Internal failure costs include scrap, rework, retest, failure analysis, downtime, yield losses, and discount costs. External failure costs are those costs associated with the failure of products, components, materials, and services to meet quality requirements after they are delivered to the customer. External failure costs include complaint adjustments, returned products, materials, warranty charges, liability costs, and indirect costs such as a loss of future business, customer dissatisfaction, and loss of market share. The total quality cost is the sum of these costs. The image you see here represents how total quality costs can be calculated from the individual quality costs. It shows the difference between the implementation cost of a quality management system, which includes prevention and appraisal costs, and the cost of not having one in place, which includes internal and external failure costs. Often overlooked, legal issues arising from quality problems can result in more than just loss of consumer confidence. The Consumer Protection Act of 1986 protects consumers from defective products and services that can cause damage or injury. While protecting the consumer, this law makes manufacturers vulnerable to legal action when products are defective and can cause harm. Product liability is defined as the legal obligation of the manufacturer to compensate for the injury and damage resulting in a defective product. Quality control inspections of key characteristics of products are crucial protection from this eventuality. In summary, there are a variety of different quality management strategies and philosophies that a company can implement to improve its overall quality. The founders of quality philosophies and strategies, although different, provide the basis of what quality means to companies today. Each quality management strategy aims to improve quality by reducing defects and better understanding their causes. Lastly, quality has a direct impact on productivity and costs. As quality increases, both productivity and cost increase with it. This is a trade-off that every company must consider. Thank you.